So, hello there. I'm happy to be here. Welcome to my talk. I would like to first introduce myself. So, I work as a security engineer in a Datadog's cloud security team, and I'm originally coming from system and networks engineering background, but the security has always been part of the job. In my free time, I also like to explore different technologies, lately playing with AI, and how I can use it in security to make my job easier and make it generally life easier for all of us. Before we start, I would like to run a short survey. If you could raise your hand if you work in a non-security role. Thank you. Please raise your hand if you monitor your infrastructure for security misconfigurations. Please raise your hand if you track the effectiveness of your cloud security measures. And raise your hand if you think that you have an efficient and working remediation process. Those people that raise their hands, I gladly invite to further connect after the talk or during the conference because I have some ideas I would like to exchange and also would like to hear your side of story, what was working and what was not working because this topic is very business specific and just having more context sometimes helps. Second, a couple of weeks ago, I have been talking with a couple of my friends that have been talking or working on some interesting projects that they told me about, and they think that it's not worth the presentation talk, so I would like to encourage them so they can just submit the conference talk and just do it. So I would like to publicly encourage them. And now, the main topic. So at the title of this talk, I am mentioning something we consider Datadog scale. So what actually is our scale? So Datadog is a company that has infrastructure spread across all major cloud providers. Our services are backed by hundreds of Kubernetes clusters, which run on tens of thousands of nodes. And these nodes are actually backed by hundreds of thousands of cloud resources. The size of our engineering team is over 2,000 employees, and cloud security team, my team, is responsible for ensuring that we are not introducing new misconfigurations into the live environments. For the context of this presentation, let's do a brief overview. What do we consider to be a security misconfiguration? When I was looking for the different definition, I came across multiple complicated definitions up to the point where I settled on short one that basically I consider security misconfiguration to be any kind of misconfiguration that makes the resource less secure. So for example, let's say that we have an open S3 bucket. We are having a security group that opens port SSH or RDP to the internet, or we are mixing control plane and data plane of Kubernetes, and so on. So why are these misconfigurations actually so dangerous? Imagine that you are a company that works with the health data and you are storing sensitive data about your customers. And suddenly imagine that this data appears publicly on the internet and you basically leaked sensitive and confidential data. This will definitely result in some of the compliance violations and regulatory authorities, they will start looking into this. This could result with certain regulatory fines and in some most extreme cases, even losing the certification or the compliance to be able to process the particular data, therefore could render the company out of business. And last but not least, all of these misconfigurations are also open for further exploitation by the malicious actors, and they could use it to wage further attacks or keep their presence within a company for months. Over the last couple of years, we had a couple of famous cloud security incidents. Most of these follow exactly the same pattern. Either the attacks or actually the misconfigurations are abused. For example, S3 buckets are publicly open, snapshots are made publicly available, therefore people can download them and get access to the sensitive data. Not all of these were done on purpose, and it's quite difficult sometimes to work with the misconfiguration. So what are the most common challenges when we have to deal with misconfigurations? First and foremost, scale. Different companies have different number of services, size of the infrastructure, providers, and they provide business across globally. Therefore, they are operating 24/7. And if you have to fix misconfiguration, all of these factors usually have implications on the operations and the remediation. In Datadog, our engineers ship functionality pretty much every single day, and this results in a vast number of changes in the infrastructure. What does it mean? That basically, if I remember something from yesterday, I'm pretty certain that it will not be the case tomorrow. Basically, we can say that what is a constant in our environment is a change. When dealing with remediations or misconfigurations, it is also important to know who is the actual owner. Example, we have a cloud resources that are used by 20 or 30 different teams, and we have no clear boundaries like who is the clear owner. Once we were lucky to be able to find the owner, then we also still need to fight for the attention of the stakeholder and engage with them. So basically, they actually carry out the remediation. And by prioritization, it's also important to know that security teams have to be aware pretty much all the time that issues or requests they are sending out to be fixed are actually the ones that are the most important to be fixed, because it is very easy to get overloaded by requests, and the more requests we are sending out, generally the worse response we get. Therefore, for security teams, they also have to have their own way how to prioritize the issues. So now let's talk a bit about detection. When we were thinking in Datadog, how do we want to approach these issues? We were thinking like when and where we do actually have to detect misconfigurations. The answer was pretty much as early as possible, and we want to prevent these misconfigurations from landing in the production environment. This was also pretty well aligned with the shift left initiative that the company is going through for the past couple of quarters. And this naturally led us to define certain requirements. First, as we want to be able to detect this as early as possible, so basically we have to provide feedback extremely early in the development life cycle. So if a developer is iterating, then we want to provide them a constant feedback loop, how their change looks from the security point of view. We also want to have a big picture view that we want to be able to scan the whole repository or repositories to be able to basically get different metrics and being able to spot the emerging trends. Let's say that, for example, there is a new set of misconfigurations coming in. We definitely are able to catch it because we are scanning the whole repository. And last, if the previous 2 points did not code the misconfiguration, we still need to have a mechanism how we catch the misconfiguration post deployment. Meaning that if the misconfiguration has made it to the production, we still need to be able to detect it. This naturally led us to focus on 2 clear areas, which is basically in the development phase, where people use infrastructure as code. Infrastructure as code is a set of practices which basically allows us to manage cloud resources as a code. And therefore, we are able to scan it or provide the best practices and iterate on the change. Basically, we can run tests against the proposed changes. And the second one is the runtime, which we consider basically anything that is deployed and is active, is providing some kind of service. How do we know what and where we want to do? We still need to figure out how. So what is the best way to select the tools? So I have a good news. There is a plenty of tools on the market. There is a plenty of open source and commercial offerings. These tools differ in different scanning techniques, different correlation mechanisms. Some of them are meant to be extensible, so basically you can write your own policies. Others come up with plenty of different compliance checks and best practices. So basically there is a lot of options to choose from. When we were trying to choose the tool, we were trying to cover our business needs and the bigger picture. The way how we approached this was that we checked a couple of tools, and then we basically make kind of a contest where we were trying to cover our needs. Problem was that we were focusing on features. So for example, we knew that we need to scan or terraform repositories, but all the tools were able to do it, but every tool did it differently. So the recommendation here would be, so instead of focusing on features, rather focus on capabilities, because features are more or less implementation details which might not necessarily be relevant. Because I haven't seen use cases where people would be able to use all of the features that the tool was offering. And when you are picking the tool, start with one and pick the one that provides the biggest value for your investment. When you pick tools, you always have to be careful with the amount of findings. It's very easy to plug in new detection tools, and it's also easy to start reporting issues. But what it will end up is that people will get overly annoyed by receiving the noise. So therefore, always start with a small number of tools, and always consider what these tools are detecting. If you're using multiple tools and the tools are basically detecting the same thing, definitely you don't need that, because those findings are going to be duplicate. And always keep in mind that it's always easy to plug in more tools, and when you are actually considering getting a new scanner, always mind the tool overlaps. So now let's talk how are we approaching detections in Datadog. So taking the previous philosophy into consideration, the big picture is that everything starts with the developer creating a code change. Then this is picked up by your CI/CD system where we are running the scans. And then once the change has been merged, it is going straight to the maintenance cycle. Basically, resource is created, and we are maintaining it until it is decommissioned. This clearly defines the areas. So basically, code change and the CI/CD fall under the development, and the maintenance or the cloud resource lifecycle monitoring is part of the runtime environment. So how do we approach infrastructure as code detections in Datadog? So we checked multiple tools, and we selected Števko. Števko is an open source tool created by Bridgecrew, and we deployed the tool in two modes, in a pull request mode and in the schedule mode. These modes serve different purposes. Pull request mode is there for providing the feedback to the developer, and schedule mode is something that is collecting data for further analysis when we are doing our quarterly objective planning. These tools are covered in a way that we have a single set of tooling. Some people could call it a glue code, but we consider it as a set of interfaces where with the different switches we can activate different modes. What is the important thing here is that when we get a finding for the particular resource, we also try to enrich it with a different contextual information. For example, service, team name, business criticality, data classification, and so on. Obviously, if the information is available. What these interfaces or tools actually help us to achieve is also that they provide standardized output, which is then further fed into the internal reporting platforms and help us generate metrics, logs, and findings. So we are basically always able to get the data. And when we are actually plugging a new tool, what helps us that we just have to write the conversion between the tool output to the standardized format. Now, let's talk a bit about the pull request mode. So pull request mode is a mode that is run of every execution of the CI system. So basically, if a developer creates a change, then they will get the feedback. We are posting comments directly on GitHub. In these comments, we are trying to provide all the relevant information, such as what is the problem, link to the remediation documentations, either internal or external, and what has to be done. So example of such comment is on the picture on the right, where basically you can see the breakdown by paths within the repository, and then discovered the impacted resources. So for example, the AWS S3 bucket would be a link within the source code, while the description of the finding is a link to the documentation that comes with Checo, or if we have internal findings, then we are linking to internal documentation. And within every comment, we are also linking to the particular dashboard which we are providing. So the pull request author has a means how to check how his pull request is doing. One important thing here is that we are not posting comments for everything. We are only posting comments for things that we consider critical or things that could lead to a problem. So basically, if developers want to see more findings, they will actually have to see it in the dashboard. On these dashboards, we are providing a couple of metrics. First and foremost, it's the total number of findings. On its own, this number is not interesting without the context, because if you see the change has 2,000 findings, is it good, is it bad, we don't know. But if you are able to provide more context and therefore provide more look at the data, so we are able to break it down by the severity, resource type, cloud provider, location within the source code, regions, business criticality, all of the contextual data that the internal set of tools are actually able to provide us, then this actually enriches the findings and provides more context. This also makes it clear which items should be prioritized. Thirdly, it's also important to be able to displaying the trends. So if the number of findings is actually growing or decreasing. This is especially important because sometimes the changes take a couple of days, weeks, and they are big chunks of changes to be merged, and people want to see how they are doing over time. What this also helps us to spot, as mentioned previously, is the emerging security findings. So let's say people are lazy creatures and they tend to copy the code snippets across the source code location. So if you see that there is a spike in certain findings, this could be the reasons, and this is the way how it can actually help us detect it. And last but not least, as this is also a service towards developer, we have to ensure the good experience, and we are also collecting performance data such as the failure rate, scan duration, and so on. What is the most annoying for developers if they have to wait more than a couple of minutes to get the data? Basically, faster we can provide the information, better the experience, and happier the people generally are. Now let's dig deeper into the runtime detections. For runtime, we are using a Cloud Security Posture Management or CSPM tool. It is a scanner which basically works by scanning active configuration of the cloud resources. So for example, if we have a S3 bucket and we see that the public equals true, this would be detected and would be considered as a finding. In Datadog, we are in a bit special situation as my team is part of the internal testers or early adopters of our own security product, which we use. But we are actually heavy users, but generally speaking, any good CSPM tool will be sufficient. Again, main use cases that we have from this are ability to detect security misconfigurations in an active multi-cloud workload. So basically, doesn't matter if it is in Amazon, if it is Azure, if it is other clouds. Basically, we want to be able to detect misconfigurations in all environments in which we are operating. Second, definitely be able to provide some long-term data, trending, how we are doing, and so on. So we are actually able to track the performance and benchmark our remediation and detection process. And definitely, this is also used to collecting data. And then before every quarterly objective, we are analyzing the data and trying to tackle, prioritize the remediation efforts if needed. On this screenshot, you can see a interface, how the tool looks like. So basically, what we necessarily need from the tool is to be able to provide what exactly is the problem, ability to identify the impacted resources, and provide a wider context within the cloud. So for example, if you have an instance, we definitely want to be able to see what is the blast radius of the particular finding. And now we know that what is the impact of the finding. We know which is the instance. We decided to fix the misconfiguration. Now comes the usual question, like where exactly is it located within the source code? Usually when we start chasing it, we end up like finding a tree within a jungle, and then after half a day of not being able to find the answer, we have to reach out to particular owners or people, and we will be able to get the answer. This is where the second mode of check code that we deployed, schedule mode, comes in. It is, as mentioned, it is basically to provide to collect the data, and the second main use case is that it is able to identify the misconfigurations on the source code level. What is a good thing is that we have the runtime level covered. We have the infrastructure code level covered. We are able to correlate findings across the different findings datasets, and therefore we know where exactly the resource is located. And we are providing exactly the same dashboard as with the PR mode, but the metrics are more in a long-term or aggregated fashion. So basically, we would see data from the whole repository, not just the particular change. Usually, the detections are the easier part, and now let's look into remediations. And remediations are a very challenging problem because they are not always easy. I put together a couple of common challenges, so let's go through them. So me as a security person, I always triage findings, and I identify the findings, I reported it to the team, and I received a message that yes, they will prioritize it. So I reached out to the second team. They told me that they will put it into the backlog and prioritize it in the next sprint planning. I keep checking every quarter, and what's happening, that 9 months later, the misconfiguration is still not fixed, and basically we are waiting for the remediation action. Now, you're looking at this from the perspective of the non-security people. The way how it looks is that I am one of many security people reaching out. You have too many requests, and you don't know which one to prioritize because all of them look critical, but you don't know if they really are critical. So over time, what happens is that the stakeholder team just will automatically acknowledge any new security request while getting swamped and not having achieved anything. Now, let's say that I was lucky. I was able to get the stakeholders' attention, and we are able to start looking into the misconfiguration. So I pretty much explain what are the remediation steps linked to the documentation. But then the remediator starts looking into it, and they realize they have to, just to be able to understand, they have to go through endless pages of documentation. They have to be able to schedule maintenance hours, do it something that's outside of norm. And then once they actually had an idea what actually has to be done, they usually get scared, and they just deprioritize it and move on. And my all-time favorite, so let's say that we have a fully working remediation platform. We are good at detecting findings. We know how, what has to be fixed. So we just have to contact the owners. The problem is, who are the owners? Because we don't know. So some of these challenges can be tackled. So in Datadog, we underwent some changes a couple of quarters ago. But basically these challenges are tackled. So what actually do we need from the remediations? So first and foremost, best way how to deal with remediation is not to deal with them at all. In ideal world, security would be perfectly embedded within the development process. So if a person actually deploys new cloud resources, they don't deploy them in an insecure fashion. However, it is not always the case. So for more realistic cases, we have to focus on simplicity. Simplicity means that it has to be clear. Simplicity has to be on all different levels. It comes to the communication, it comes to the notifications. Basically, we need to clearly explain what is the impact, how to fix it, and what is the remediation steps. If we are having systematic problem with the particular set of misconfigurations, it also requires systematic approach or systematic response. Therefore, security should definitely start looking into how to automatically remediate certain family of security misconfigurations. And this way, it becomes also more time efficient. And therefore, if the stakeholder has to spend less time, it's more likely to be prioritized. And also important thing is to always to drive the stakeholder engagement, make them part of we have to be able to get their attention early. We need to make them part of the solution, so they also contribute because they are the ones carrying out the work. So now let's talk how do we approach this in Datadog. So in Datadog, we split the whole problem across multiple security teams, and we started by forming the security community within the engineering department. The backbone of this is our security champion program. Security champion program is an approach where every team appoints a person who is a point of contact for security requests. This person then undergoes trainings, is part of the workshops, is part of the wider security community, and we are also integrating these people to work closely with the security team. So basically, anytime when we are actually creating new tools, procedures, and processes, they are always part of the solution. This also comes especially handy for the incident responders because, for example, if you have an incident in a cloud and we don't know what is the context, what is the importance of the service, these people are able to provide us required information. Also, as mentioned previously, in cloud security, we definitely stick to the approach that we are, how does the quarterly objective look for my team? So basically, we always look into the dashboards before the objective planning starts to see what we could prioritize. And then if we see certain findings data, we also try to engage with particular stakeholders. So see if they actually consider it as a problem, and if they could actually help us. Usually they are helpful, and what we do is that we start by writing the problem statement, and once we have written the problem statement, we ask them for feedback, and we always ask for next milestones that we are trying to iterate in a small steps. So basically we are always trying to tackle we are able to take small amount of work, so basically we work iterations. Why this approach is beneficial is because because we are doing smaller changes, and once we reach the milestone, we get the feedback. But if the feedback is negative, or in a sense that the tool is or the process is not needed anymore because the problem has been resolved in a different way, it allows us to actually fail fast, and then we actually know what was working and what wasn't working for the particular case, and this actually provides us lessons learned, which then we reuse in the next planning. On the development, we use Terraform to manage cloud resources, and we are providing Terraform modules for most commonly used resources. So basically, if the developer requires an S3 bucket, they will use an S3 bucket module, and that's it. They don't have to deal with the security settings, encryption, ACLs, and so on. So basically, this approach helped us cover more or less 80% of the use cases. And people who actually have a different needs, then they usually reach out. So basically, we are also able to catch those cases. We started using this for all of the new resources, and this actually gave us an ability to roll out remediation at scale. What I mean by this is that basically, let's say that there is a new security option, or there is an insecure setting in a particular version of the Terraform module. We would just update the version of the Terraform module, implementing the new features, bump the version number, and then tell people to basically, to fix this, you have to use version X of this module. Every company has some legacy code, or they are using raw Terraform resources, which are more complicated to configure it sometimes. What the recommendation here is just to prioritize the migration of existing resources to modules, as they provide abstraction, some developer abstractions which can be used to improve developer experience, as well as the security settings. It requires some effort, but in the mid to long term, it will definitely pay off, because this is also a way how you can enforce good practices for observability, cost tracking, permissions, tagging, and so on. Example from our internal documentation, S3 bucket module. So basically, we simplified the interface. Basically, if a person at Datadog needs to deploy S3 bucket, he has to provide only 3 arguments. On the picture in the bottom, you can see security settings. They are not required, and by default, they are set to true, meaning that people have a chance to override it, but in most cases they don't, because the security best practices are provided in the development within the default configuration and as development best practices. One of the main drivers for actually adopting the modules also has been the simplification of the code, because basically we went away from raw Terraform resources to a module, and this basically decreased the amount of code that actually has to be written. All of the magic happens within the module based on the arguments, and developers don't have to pay attention to that. Obviously, there are more configuration settings for the module if you need to modify the settings of the S3 bucket, but in the general, basically 80% of the use cases are covered by a couple of lines of code, which has been a huge time saving and also improved the experience significantly. Last pillar of our remediation is something we call automated remediation. This works on top of Cloud Custodian. Cloud Custodian is an open source tool which actually allows us to write policies for the cloud. It can actually locate resources, fix them, delete them, and so on. On top of this, as mentioned, we build an in-house solution. And this approach works in a way that we scan cloud resource configuration on a regular basis and apply the fix as soon as possible. This approach generally works, but is not the most fortunate way of doing things, as it contradicts with the infrastructure as code or the infrastructure as code approach. So for this reason, what we are doing is that we are picking only a couple of specific security misconfigurations. So for example, if an S3 bucket or opening SSH or RDP or databases to the internet, so basically things that could actually lead to an utter catastrophe are basically remediated immediately. Special case has to be taken when we are actually deleting resources. So we wanted to ensure that no resources ever get deleted, so we don't even have permissions to delete resources. This has been a requirement also by the infrastructure team, but because they wanted to avoid resources disappearing and basically having problems with the Terraform state, because we are modifying the resources outside of the state. To conclude, security is already hard enough, and we don't need to make it harder. Most companies are extremely good at detecting issues, but they just suck within the fixing them. And remediations is where actual emphasis should be put on. For all non-security people, I would definitely encourage you to provide feedback to your security team members. If you have to use a process, tool, or other items developed by the security team, but the tools are hard to use, they are not usable, or you have a problem with them, give them the feedback. They will definitely listen. They will be happy because somebody is actually using what they are developing, and you are actually giving them feedback, and I mean that is a reason to actually keep moving on. The main driver here is that the feedback coming from the stakeholder teams is important, and people should not be afraid to talk to security. And when you are actually starting with the remediation pipelines, my personal recommendation is start small. Basically, be able to detect some findings and have a well-defined remediation steps for them. It's always better to be able to fully cover 3 misconfiguration types than being able to targeting 2,000 misconfiguration types, but not being able to remediate none of them. So in this context, less is more. Thank you. I would like to invite you, let's connect after the presentation if you have some ideas or what works for you in your company, and I am happy to take questions.
Hi. Yeah, you've got a lot of them as well. So, well, but I'll try to group them.
No
yeah?
worries.
I thought it would take more talks about this, but they're asking if your organization is impacted by the recent Terraform drama, let's say, and if you have any plans to go to OpenTofu at some point. I know this would happen at some talks.
Yeah. So I will not speak entirely about this. I think we are monitoring the situation so far. What we have done was that we stopped basically internal recommendation is to not use Terraform version beyond 1.5.7. Basically, anything that has the license change is being reviewed by the legal department currently. So we are in a state of in the state of evaluation.
Okay. Another big topic, let's say, is, and probably there's no good answer for that, but how do you keep a balance between all these checks and speed? You know, because obviously you need to deploy multiple times and.
Yeah, so that's the thing, that the reason not all misconfigurations are equal. What we are trying to do is that we have tried to define the security posture between our baselines in a way that things, basically we try to do some kind of a threat modeling situation over the infrastructure. And outcome of this was basically what is the most critical thing that could have happened, and we are trying to focus on that. So for example, if somebody opens a SSH or RDP port to the internet, an instance gets compromised, that's definitely a lot more impactful than not having encryption and rest somewhere. Not saying that we don't need to have encryption and rest, just trying to say that priority between certain findings that can be actively exploited are the ones that we are trying to prioritize.
They're also asking if you can recommend some good tool for CSMP, if you can, like, because recommending is always, you know.
Yeah, well, I would we are using the Datadog security tool. I personally am happy with the product, but there is also other competition out there. Definitely, recommendation I can say is evaluate more of them, and this is definitely something you should buy, not build by yourself.
They also ask if you have any sort of automatic remediation, or there's always some double check before applying some change.
We do have automated remediation. Basically, the configuration is rolled back, but as mentioned, it is only done for particular findings. We are not automatically remediated 100% of what we detect.
Right, and then around the checkoff solution you're using, they're asking first if you are using the standard open source solution anyone can download, or you have some customizations. And then if you have the same rules across all repositories, or it's customized per team, or if you can speak a bit about that.
Yeah, so basically we chose Števko because one of the main drivers behind Števko was that it has a lot of policies. We are using the open source version. We are not using the commercial offering. All of the tools that we actually wrote are internal, but we are using the open source version. We are having multiple repositories, and basically we are not doing any customization. We are scanning all of the resources in all repositories. And also we are running a couple of internal checks, and these are actually shared across all the repositories.
And probably some final ones. It's more around the relationship between your team and the developers, let's say. Do you have a lot of requests from them helping, or they can be self-sufficient? It's probably a question for HR, maybe even, but how does the relationship work in terms of like enforcing them and them replying you and they being,
That is a good question. So basically, a lot of good is coming from the security champion program, because usually people who are somewhat interested in security, they work with us, and we are trying to piggyback on that. When we don't have a security champion in some teams, because, for example, teams are undergoing changes, let's say that they are merging or disbanding and so on, what we do is that we always try to engage with the engineering manager, trying to explain what is the problem. Or basically our philosophy is that we are not trying to overload them. So basically if we reach out, we try to reach out because it is a problem, not because we are bored. So basically there has to be action taken. If action cannot be taken, we are definitely feeding it into a risk acceptance process. So basically we are trying to get some kind of action done. Not fixing a misconfiguration can be, not fixing a misconfiguration is an accepted solution, but there has to be a reason why, because maybe particular misconfiguration is actually a feature, not a bug, but then there has to be usually the compensated control, and this is when the GRC and the risk control, risk management teams actually come in.
And like, again, somewhere in these lines, like how do you make sure that they use your own, your Terraform modules? Do you have some sort of like doing wrappers on top of the open source Terraform modules? And how do you encourage the developers to not write resources and use your Terraform modules?
Yeah, so what we are doing that, for example, for certain resources like IAM, we are actually mandating the use of the module. So basically, this is a part of the the CI/CD pipeline. For the others, we are basically, if we detect the use of the non-standard module, or it's something that is not necessarily maintained by Datadog, we basically post a notification and people are able to do whatever they want. What we are just trying to focus on is that all of the internal modules are built in a way that they comply fully with the internal best practices. So basically tagging, security settings, cost tracking, permissions, observability, and so on.
And the final one, this is around Kubernetes. Are you using any open policy agent inside the cluster like Kyverno, which I don't know what it is, or do you have any thoughts on that?
Kyverno. My team is not directly dealing with Kubernetes. From what I know, we are using something that's called Gatekeeper. Though I would, if the person can come to me, I can try to provide the answer after the talk.
All right. Thanks a lot, Adam, for all these answers. And thank you, guys. Enjoy the break.